The broadcast is now starting. All attendees are in listen-only mode.
Well, welcome everyone. We'll give this maybe another minute or two, then we'll get going with the presentation. Have everyone unmuted at this time, but we'll throw it back on the mute once we start the webinar. Okay, we're about 2 minutes past the hour here. We'll get going. Again, thank everyone for taking a little time out of their busy schedule to join us for a webinar series that we here at SBS hope to continue on throughout the year, kind of highlighting different topics and talking points that both our subject matter experts and our customers care to hear more about in the way of best practices, in the way of using our Substation Design Suite tools. So we'll go ahead and get started. Just some quick introductions. My name is Dwayne Guidry. I'll be your moderator for the event. We have, I call the Dallas, Texas area home, and I have revenue generating responsibilities here at SBS for both our distribution design products as well as our substation design products. One of my colleagues who is, I'll call him the headliner today, is Nate Holt. Nate Holt is one of our subject matter experts around the SDS protection and control electrical module. Nate is a veteran of this profession, and he calls the Toledo, Ohio area home, and he will be taking us through the technical portions of the webinar. Just a couple of things here. I thought, can everyone see my screen? I think I've gotten a text saying that folks can. I assume that everyone can hear me as well. I tried to turn everyone back on, but apparently not. I guess GoToMeeting wants everyone muted at this time.
I can hear you.
Okay.
We can hear you.
Oh, okay, great. The dashboard appears to show that no one could hear me, or no one could present. If we could, just out of time constraints, if we can save questions to the end of the presentations, there will be a Q&A session at the end of the webinar that should provide some time for Q&A with Nate or myself. Also, this webinar is being recorded and will be posted to our SBS YouTube channel, and it might be also some posted on the Sds Industry Consortium website as well. So, and I'll probably send out a courtesy email with those links. So just a little background. Most of you on the phone probably already know this, but it doesn't help for those that are kind of viewing this for the first time. What we're presenting today is the part of the Substation Design Suite, which is basically 2 purpose-built modules for substation design, one around the physical design aspects of building a substation, second aspect being the protection and control electrical design, which we're going to highlight some of the advanced checking capabilities within that software module. These modules are built on a very popular, very robust engine. The physical design module is a plug-in into the Autodesk Inventor product. So we leverage the rich parametric modeling and design capabilities of Inventor for our SDS physical purpose-built design tool, and here with the AutoCAD for the SDS protection and control module, we leverage the popular and rich Autodesk AutoCAD electrical product. So that's the engine that we will be running off of today. As we get started, some of you on the phone may already be members of the SDS Industry Consortium. If you are not, or I would encourage you and encourage your colleagues as substation design professionals to join the SDS Consortium. It's free, it's easy. The website of sdsconsortium.com, becoming a member allows you access to your peers in the industry, both in the engineering, EP, EPC community, as well as the investor-owned utilities, manufacturers, munis, co-ops. It's a pretty rich who's who in substation talent across North America. Currently, there's about over 700 members and growing, represented from a lot of different organizations, as you can see on the screen. So we welcome participation. This is not run by SBS. This is run by the consortium members. The beauty of this particular getting involved with the SDS Consortium is they meet twice a year and basically are split into 5 different committees where your voice is heard in helping direct best practices as well as capabilities and functionality and the future direction of the products that we are showcasing within the Substation Design Suite. Got to give a plug. Our next meeting, it's held again twice a year. Our friends at Con Ed and Power Engineers will be hosting in April at a Con Ed facility, April 8th through the 11th. If you go to the sdsconsortium.com/event, SDISC-New York City, registration is free, attendance is free. You just need to get there, and everything else will work out for itself. So I'd encourage you to join that and mingle with your peers in industry. With that, I will turn it over to my colleague Nate. Put everyone on mute. You are not already on mute. And turn it over to Nate. Nate, you should have control now. And Nate, I can't hear you.
Okay, you can hear me now, right?
I can hear you now.
Okay, thanks, Dwayne. Okay, I'm going to show you some tools for doing automated design check, and maybe not totally automated, maybe semi-automated. A number of tools that we've put together that run on top of AutoCAD Electrical. So if you see my screen, we have the normal AutoCAD Electrical ribbons displayed. And what we've done at SDS is SBS, we've added an additional suite of tools that are specific or help folks with doing substation design using AutoCAD Electrical. These tools are compatible with AutoCAD Electrical. They basically just enhance or extend the capabilities of base AutoCAD Electrical to make life easier and for the folks doing substation design. So let me just run through a few of the tools that kind of fall into the design check category of our tool set. So I have here's just a sample drawing here. This is a 3-phase drawing. I want to show you, and if you're not familiar with AutoCAD Electrical, basically wires are nothing more than line entities on a layer that you've defined to be a wire layer. And you can have as many different wire layers as you'd like in your design. Now in this particular example drawing, we have 3 different layers for wires. We have the bus, the high voltage bus, and then we have external wiring, like going out to the CTs, and then internal wiring inside the control house panels or whatever. Green is the internal wiring, blue is the external. So I have a tool here. Let me show you the regular AutoCAD electrical tool first, then I'm going to show you our enhanced version of the Show Wires tool. So let me go to the regular AutoCAD electrical schematic and go to the Show Wires tool. This is the AutoCAD electrical version. Hit OK, hit OK. And basically it lights up, or it highlights every line entity that's on a wire layer. The difficulty or the problem with the AutoCAD electrical out of the box version is as soon as you, let's see, you want to zoom in and see something here, as soon as you zoom in, it unpaints everything. So let me show you our SDS version of this command. So I'm going to go to the SDS ribbon right here. These are the tools that we've added. I'm going to go to the show, whoops, I have to type this one in. Hang on a second. Okay, so here's ours. It looks the same right now, but it has some additional options. If you look down here in the command window, I can actually cycle through the different layers and display layers one at a time, my wire layer. So I'm going to hit the space bar. Right now it's showing wires above 600 volts. So you can see them lit up. And I can also scroll around and they stay lit up. Now let me hit the space bar again. Now we're looking at the internal wiring. So that would be up here. You see it's lit up. Now let me hit the space bar one more time. We'll see the wire, external wiring. There it is. So there's this tool is very handy for showing one layer at a time, and then you can zoom in and make sure that you got everything. Now this tool also has an additional capability that will detect when you have a zero length wire. This happens more frequently than you'd like with AutoCAD Electrical. There is a chance sometimes that you, when you're hooking things up, you may generate a short or a short length or a zero length wire. So our tool is also looking for that condition, a wire that's very, very short or zero length. It draws these little arrows pointing to it. So I can zoom in, and I'm going to hit escape to get out of my command, but I can see, sure enough, there's a little chunk of line entity right here that shouldn't be there. It must have gotten in there by mistake. So I'm just going to delete it. So this tool, the Show Wires tool by SDS, the SDS tool set, takes the existing AutoCAD Electrical Show Wires command to the next level and adds a number of additional functions to it. Okay, let me show you another tool that we've added, Show Phase tool. The Show Phase tool, if I click on a wire, it will follow that wire through terminals, it'll follow it through fuses, it'll follow it through test switches to show me, I'm looking for continuity, okay? So let me go to the Show Phase tool, click on this, and I'm just going to click, just pick on a wire here. Now I pick on this connection between these two terminals. You see it all lights up, so it's reading through the terminals, but it's also reading through a source destination. So you see it lit up down here as well. So it's showing you the phase the phase that I selected, the wire I selected, it actually continues down here. Now, if I hit space bar, I can hit another wire, and it will. And let me do it again. Let me do it again. So here I have the four phases, or four common wires coming off my CTs, and I can again zoom around, scroll around, and I can follow them around to make sure that I've got these things. Let me go down to the bottom. You see them continue down here. Okay, so that's our show phase tool. Now let me show you the a similar command. It's called a trace phase tool, which will allow me to surf to all connections across the project that wire ties to. So here I just picked on this segment, and it shows me, brings up the normal surfer window. And it shows me probably 50 or 60 places where this wire, this phase, eventually touches something, touches a component, a terminal. So anyway, and I can click on any one of these and it will surf. I can surf right to that particular connection. So this is a very nice tool when we're dealing with, well, like CT circuits that may span multiple drawings in our project set. Okay, now let's look at, let's go to a different drawing here. This is a very busy drawing. And there are a lot of source destinations. I've got a lot of connections. For example, in this CT, these guys wrap around and continue through some cables, terminals, junction box out in the field, the panel in the control house, and test switch, and so on and so forth. But anyway, these little symbols here are regular AutoCAD electrical source destination symbols. Now, AutoCAD Electrical does have a tool to display temporary graphics that shows you these interconnections, so you can check them. But the problem is with the AutoCAD Electrical version of the command is as soon as you try and zoom in to get a closer look, all the graphics disappears. So what we've done is we've created our own version of that AutoCAD Electrical tool called Show Signals. I click on it, and I'm just going to window a couple of these guys here. So it shows me that this wire continues right down here. This one continues over here. And basically it shows you where they continue. And the neat thing is that I can zoom around, pan around, and if I got something wrong, I can troubleshoot it and make the appropriate adjustments on the little SIG codes that are carried on these symbols. I can also, I just want to show you how complex this drawing is. I'm going to rerun the tool and just window the whole drawing. Wow, look at all these. So there's jumps all over the place, and the cool thing is I can zoom around, pan around. I can't do this with regular AutoCAD Electrical. I can with the SDS tool set. So here's okay, so let's move on. We've also added another tool, let me escape out of this, called our Rollover Tool. This is a multi-function tool, but it's great for, in some cases, doing troubleshooting. If I hit Rollover, and I can roll over one of these source destination signals, and you see that, let me make this bigger here so you can see it. So as I roll over the source destinations, I can see, it draws the little chicken tracks here, going back and forth between them. So this is another built-in troubleshooting tool in SDS tools, the Rollover Tool. And this Rollover Tool can be used for many other things. For example, if I roll over terminals, it shows me which side of the terminal is marked as internal, which is green, and external, which is the red arrow. So this is great for dealing with your wiring diagrams. to get the wire connections to show up on the correct side of the terminal strips on your connection wiring diagram. This thing will help you troubleshoot or find errors that you've made in your schematics. Because remember, with AutoCAD Electrical, the schematics drive the wiring diagrams. Okay, so that's the just one aspect of Rollover. It's got about a dozen other features or capabilities, but that's the one I want to show you here. Now let's move to a different drawing, and I want to show you tracking cable color code assignments. There we go. So here's a DC drawing, and let me zoom in, let's say down here. So what we have to do, our smart schematic, our schematics need to show all terminals and all cable connections. That needs to be embedded in the schematic. Now you don't have to actually have them visible. You can put them on a layer that, if you want to turn them off. I have all the layers turned on here, so I am seeing my cable markers here and all my intermediate terminals. This is a junction box, I think that's like a marshalling cabinet junction box. So let's look at this cable marker. This cable marker right here, 131, it's marked as an orange. It's an orange conductor in that cable, but this one does not have a marker, an assignment. So let's take a look at that. So I'm going to right click and edit this cable marker, and it brings up the normal AutoCAD Electrical list box here. So let's go to, let's see what markers we've used so far. Well, we've used red. It looks like that's the only one for cable 130. So I'm going to mark this one as, I'm just going to pick this guy here. Okay, so this is normal AutoCAD Electrical functionality here. Now watch what happens when I go over to cable 131. Let's take a look at it just for fun. So right click on it, edit component, get the last list again. And here we're seeing that this particular cable, cable 131, it's a 19 conductor cable, 10 gauge, and it looks like there are two conductors in this cable that have been marked as blue. So one of them, we need to fix this, okay? And the ones that are still available are the ones here in these that don't have an X in the column here. So let's find the blue. There's two of them. Let's find one of them and flip them to the correct color. So I'm going to right click on this guy. Again, I'm going to hit the surfer tool. Surf on cable 131. And it looks like I have a blue here. Let's see, there's another blue somewhere. There should be. Let's go up. Okay, yep, there are two blues. So I'm just going to surf to one of them. So I double click on it. Takes me to it. So there it is right there. And I'm going to edit it. And I'm going to hit project list. It's going to give me all instances of cable 131 in my entire project. I'm going to flip this guy to be, I don't know, I'm going to pick red and white. Hit OK. Okay, boom, we're done. We got it. So let me show you another way to detect if there are duplicates. So I'm going to undo, get back where we were here. Let's see, undo, come on. Oh well, I'm just going to temporarily change this back to blue so we get doubled up. All right, if I run a cable from to report, let's do that. And it's going to detect when there are multiple assignments, color assignments. So I go to normal AutoCAD Electrical Reporting. I'm going to do a cable from to. Do the whole project. This is just normal AutoCAD Electrical here. And as soon as the report displays, I'm going to select a custom option that we have added to the cable report that will search for and detect duplicated conductors. So I'm going to get the flow report here. Let me turn these on. Okay, so here's a report, and I'm going to go to user post, and I'm going to select this right here, QA check. So this is something we've added here at SDS. If I pick this option, hit OK, what it does is it scans through the report and looks for any entry that has duplicates, duplicate color codes. So for example, looks like it found that in cable 91, it's a 4-conductor cable, it looks like red is used twice. Now cable 131, the one that we were messing around with, and then I did the undo, it detected, yes, blue is used twice. So it shows a little arrow and a question mark pointing at it. So those 2 cables in my entire project are cables that have a color assignment that's been, has been duplicated incorrectly, should not have been duplicated. So now, what would be involved to do this by hand? Just using straight AutoCAD electrical, it would be more painful, okay? So this report really saves some time. All right, let's look at the Schweitzer relay here. So we have a 311C on this drawing, and we have a bunch of the inputs and outputs are wired up. But let's say that we needed another, let's say another output. We're going to put it in right here. So I've got 2 outputs here. These are the high current outputs. I think this relay has a third one, but I'm not sure. But let's say that I need a third high current output. So I'm going to go to my icon menu. I'm going to go to PNC relays, and this is a custom menu. We've kind of this is a regular AutoCAD electrical menu, but we've customized it for protection and control. We've had CTs and protection control relays, test switches, so that stuff's been added in. PNC relay, I want a high current input or output, I'm sorry. I'm going to drop it in right here, and I'm going to hit this list button right here because right now it hasn't been assigned. It doesn't have an output number. I'm going to hit the, first of all, I need to assign it to the relay. So I'm just going to use parent sibling, click on this, boom, we're good. Now hit the list button. And it's going to show me what contacts are still available on this particular relay of that contact type. And this is a high current contact. And so it looks like A5 and A6 is available, and I can go ahead and click on it, and boom, I'm ready to go start wiring it up. Now, just for fun, let's do a regular output, not a high current output, and see if we get a different result. So go back to my icon menu. I'm going to select the normal output, not a high current, drop it in. I'm going to attach it to this relay. I'm going to hit the list button, and we see now that it has, why did it do that? Kind of messed up my screen here. Let me try it again. List, there we go. So it looks like I have 4 of that type of contacts. So I'll pick one of them, and there it is. So I could be popping these things in maybe on the alarm circuitry on another drawing. All I have to do is relate back to this particular relay's tag name, R1, in panel, I think this is panel P201, and it will figure out what contacts are still available, have not yet been used on this relay. So this is another kind of an automated design check. It helps you keep track of what's been used and what's still available. All right, let's move on to cable schedule. I think I have like 10 minutes left here because we want to leave some time for questions. So let's go to, let's see, this drawing right here. Oops, not that one. Here we go. All right, so here is, let's pretend like we're doing a brownfield project. So I have an AutoCAD Electrical Smart layout of my control house. And I've added in just a rough outline of the trenches, and I've marked items, just kind of faked in some of the equipment that I'm going to be touching in this brownfield project. So I'm going to be touching 2 transformers, a couple circuit breakers, and some other pieces of equipment. I'm either adding these things, or I'm modifying them where it's going to require some changes in the cabling between the equipment and then back to the control house. Now, this is a tool that's been recently developed by SBS for doing cable routing and cable length calculations and cable voltage drop checks. So let me kind of quickly give you an idea of what this is or how we made this work. So we have just a generic 2D drawing, AutoCAD 2D drawing to scale, and we've added what we call work points at junctions of trenches and at beginning and ending of conduit runs. For example, this piece of equipment is circuit breaker 4. I have a work point that identifies the panel on the side of the breaker where my connections are going to go. And I also have a work point identifying a conduit leaving that panel and a work point showing the other end of that conduit where it touches or where it enters into this particular trench. So it's a matter of putting these little, what we call work points, and you can hide these things. We put them on a layer that you can hide. You identify equipment, trenches, conduits with these little work points. And these work points are in 3D space. Even though this is a 2D drawing, you can give them a Z value if you want to. And these work points kind of work like maybe like a nail board. Where you're wrapping your wires, the nails identify the route of the the cables, and we could calculate the lengths and the routing paths. So let me demonstrate that because our time is quickly slipping away. So I'm going to go to the normal AutoCAD Electrical Cable From To report, but we've added some cool stuff to it. So I go to Cable Report, Cable From To. I'm going to do the whole project, hit OK. So this will take probably 30 seconds or so for AutoCAD Electrical to process this Cable From To report. So it's running. Okay, here it is. This is the normal dialog you would see in AutoCAD Electrical. I mean, it is AutoCAD Electrical. And this is the normal report you would see in a moment as soon as it comes up. Okay. Now, so it's showing the cable number and the from and to locations. Now let me show you some of the stuff that we've added here. If I go to user post and I select this option right here, work point data file. This work point data file could come from either the Inventor model, maybe if you're doing a greenfield, or from this little 2D drawing that you've created if you're doing a brownfield. So I turn that on, and I have some options here. I'm just going to turn on this option here. I'm going to add, for my cable lengths, I'm going to add an extra 10% to the calculated cable length. Okay, so I hit OK. And it asks me to, I've extracted all these points into a little text file. I didn't show you that, but to save time, I'm just going to select the one that I already have. And it's processing the data, and here we are. So let's take a look. Let me make this a little bit bigger so you can see it. All right, so it's added a column right, where'd it go? Right here. This column is the calculated length of, for example, cable 37, which is going from circuit breaker 4 back to the marshalling cabinet, JB1. It tells me that it is 3,030 inches long, okay? We're in unit inches here in this drawing. So that's the length of the cable run plus the extra 10% that I ask it to add to the cable length for extra connection at the end. Then here's my cable routing. It's starting at CB4. It's jumping into conduit 41, which hits trench number 2, which hits trench number 1, and trench number 1 is what leads into the control house, and it ends up in the marshalling cabinet JB1. So here's my routing path for this particular cable, cable 37. And it also does a voltage drop check. Let's say I had it set up to default to a 30 amp inrush, and the cable was selected in AutoCAD Electrical to be 12 gauge. I think it's a 12 number, 4 conductor number 12 right there. And so it does a lookup, and it has the ohms per kilometer per 1,000 meters is 6.6 ohms. So it looks at the length, 3,030 inches, multiplies it by 2 because we need to, the wire out and the wire back to get the total resistance of the circuit, calculates it to be 1.016 ohms total. And with our 30 amp inrush, we're going to have a 30 volt, 30.5 volt drop. Okay, so this tool helps me perhaps identify cables that maybe need to be sized a little bit bigger. So what I could do here then is go to cable 37 on my schematic, right click on it, and select a 4 conductor number 10. And then rerun the report, and my voltage drop would probably be more in the area of 15 volts instead of 30 volts for a 30 amp inrush. So this tool, if we look, we can scroll down, we can see all these cables that carried a part number assignment. The tool is actually processing it and calculating the potential voltage drop, the worst case voltage drop. Okay, so what else can we do with this information? Well, we have the routing path. What I could do is I could find every cable that runs through, let's say, trench number 4, or every cable that's going through conduit 041, because they're all listed here. So let's do that. So if I go to user post right here, and I select duct schedule, click on this. I'm going to turn this off because we already have our report displayed. Now watch this. This is cool. Hit OK. And what it does is it took that report's data, reformatted it so that now I have a report showing me Conduit 2, 002, has these 5 cables in it. Conduit 5 has these 3 cables in it. Trench number 5 has these cables running through it. So what can we do with this data? Well, why don't we try and calculate fill and check to see if we've overfilled a conduit or overfilled a trench. Okay, now we're still working on this here at SBS, getting this done, but we have this much in. Here's the circular mills collected for example, these 5 cables here, they sum up to be 93,763 circular mills. So what we're going to do next, and I can't demo that today. If we do this next week, I could show you. We will show you the minimum conduit size at 40% fill that would be required to be applied to Conduit 002. So stay tuned. We're going to get this working here in the next before our next release, which we're hoping to have before the consortium in April. So that's kind of where we are with these tools for doing automated design checks and semi-automated design checks. And I think I'm going to turn it back to Dwayne.
Okay. Thank you, Nate. Appreciate that. Let's, I guess we'll kind of open it up for questions now. Let me see if we can have the attendees unmuted. So if you're out there and you have a question, you should be unmuted. If you unmute your device, please ask your question.
Hi, this is Nelson from Eversource.
Hey, Nelson.
Yes, sir.
Good. I had a question in regards to the Inventor portion for the routing lengths. How does that work with the electrical?
Okay, so what we would do, or what we have set up, in your model, your Inventor model, you would insert work points, and that's a standard feature within Inventor. I mean, basically you just pop in the work points. Now, is Steve Kaufman on the line from SBS? Is he?
I do not think so. No, Steve.
Okay.
Yes, Nate, I am here.
He is. A special
Thanks,
guest.
Steve. Can you maybe answer this question? What would be involved in putting the work points in on the Inventor model?
So in the Inventor side, you would place a part in your general arrangement and place work points in that part by editing the part. As the work points get in, you name the work points. Each work point, we have rules for naming the points for trench and for conduit. And then you run a short little iLogic that exports all the XYZ data of the work points into a CSV file. From that, Nate takes it in and he has all the points, XYZ locations for his cable paths.
Thanks, Steve.
Thanks, Steve.
And basically, we have the same thing at the AutoCAD electrical end. If you're doing brownfield and you don't have a model, we have a tool that basically mimics what Steve just described for the Inventor part. So either one, they both generate the same data, and then AutoCAD electrical SBS tool set takes that data and generates the cable schedule and does the voltage drop checks and does the conduit fill check.
Oh, okay. Thank you very much.
Thank you.
It'd be nice to see it in the Sds Consortium doing it in Inventor.
I plan to show. I'll be there, and we'll do all sorts of cool stuff, I hope.
Oh, cool.
Looking
Thank
forward
you.
to it.
All right. Thank you, Nelson. Any other questions? Now, we can't let Nate off this easy.
Yes, you can.
Stump
Yes,
the
you can.
professor. Stump Professor Holt. I can't.
I will say that I do hope to see everybody at the consortium here in April, New York City, and we'll be showing this and more in greater detail.
Okay. Well, appreciate it, Nate. If there last call for questions, at least live questions. If you prefer to send your question in otherwise, or if you would like to have maybe a more detailed demonstration or discussion about the SDS protection and control tool itself, you can email me. Email's on the screen, and we'll get the appropriate answer for your question. Or if it's scheduling an event, be happy to coordinate that for you as well. So going once.
I have a small question.
There we go.
If I may, yeah. On that last cable and conduit list example, so would you be able to, instead of just listing the size of the conduit, would you then be able to check to see automatically if maybe get a report that any conduits or trenches that are overfilled would be reported?
Yes, yes, absolutely. Yeah. So what we'll do is we'll we gather up the we get the sum of the circ mills going through the particular conduit or trench, and if you have not identified the conduit size, then we will display the minimum required for 40% fill. But if you have identified the conduit size, and actually, Dwayne, can you make me presenter again?
Absolutely.
All right, so let me show you what we're planning to do. So let me find an example here where I have, okay, right here. So this particular transformer symbol, this is on my brownfield, I just faked these in. I have conduit, I call it conduit number 5. And I said in these curly braces, I said size equal 2. So that means I've defined this as a 2-inch conduit. It's probably way too big, but that's what I did here. And so this conduit, which starts here and travels to here, same code, C005. This is a trench, and then makes its way back through trench 4, trench 1, back to control house, and so on. Anyway, that is defined as a 2-inch conduit. So in this case, in my report, I would see, oh, that conduit sized at 2-inch. I'm going to check all the, look at the circ mill accumulation for all the cables that do go through here, and calculate to see whether it's below 40% or not of what's available for 2-inch. If I didn't define it here, then my report's going to give you the minimum required conduit size. So the answer to your question is yes, we're going to do that.
Okay, thank you.
You're welcome. Another question. Come on, folks.
Thanks, Rick.
Anybody else?
Sorry, this is Nelson again from Eversource. In the report itself, is there going to be a way of highlighting, maybe like in red or something, some issue areas as you're looking at the report?
Yeah, okay, we can't do that. I don't think we can do that right in our user post, but you can export it to an Excel spreadsheet, and then maybe we could have a macro that would go through and highlight anything that's, the fill is greater than 40%. Maybe I'm just kind of blue skying this. When we run a report, we'd have an option to push the exceptions out to an exception report. So that might be even better. Another option. So yeah, that's a good idea. I mean, thanks for bringing that up. Again, this is a fairly new feature, and we're trying to, this is great feedback. All right, anything else?
Yeah, obviously, anytime you can flag, discrepancies or potential errors, that makes it so much easier for the designer to go in and just check everything that's highlighted.
Agree.
I guess you have some of that, I think, already, like in the physical, on the physical side.
Sorry, I missed the first part of this. Can you repeat it? I'm very sorry.
Well, I just said that it's, yes, very helpful whenever you can to flag, have a system that flags errors so that the designer can check easily, visually, and,
Right.
anything that's flagged.
Right, right.
And Rich, yeah, you are correct on the physical design module. That there are also a large variety of design checks, face-to-face clearance checks, and things of that nature that is available to the designer to catch those errors and omissions in the design tool versus when you get out to build the structures. So yeah, good question.
All right. Hope to see you when you're in our neighborhood.
Come up to Con Ed, Rich. Looking forward to meeting you.
All right.
Anything else? All right. Well, let me, Steve or Nate. I'm going to just get my screen back up on there one more time here, and such. So, if there are any questions, feel free to send me an email, and I will definitely get the appropriate internal resource to respond or the question answered. Otherwise, hope to see a lot of you folks up at Con Ed next month. In April. And again, appreciate your time. Thank you.
Thank you. Bye, everybody.
Thanks, Nate.
Bye.